Hey, Adam here with Canadian Hobbies, KXRD, Kirkwood Experimental Racing Development. We're in second video, and this video is regards to building the full mid-motor conversion for the whole chassis. This is with the custom chassis. Either you have a carbon fiber 3mm thick carbon chassis or a 3mm 6061 aluminum chassis. This is a full-fledged kit. Everything that you would need to convert it will be included. We are going to be building up the real street. The outlaw variant is built the same way. It just has a different shock tower, and has like a different battery tray, more for a drag pack battery. Also, is that depending on what version you do decide to purchase for the outlaw, it will include, if you purchase that style of the kit, it will include a pair of like 50mm touring car shocks for the front end, which will involve you swapping the eyelet from the original shocks that you had, the original Losi, on the front on the shocks, just so they fit in the arms. But like I said, we're going to be building it as the real street, using the real street front bulkhead, so you can retain using the stock shocks that are on the car. Without further ado, let's get going. So we're gonna continue on from the first video, the first teardown. So from there, what's not shown is this little bracket. We don't need it anymore. It's on the bottom transmission, so I'm pulling that out of the way. That way, it's out of sight, out of mind. We're just going to continue ripping this thing down, scavenging all the hardware on it. Might not need it, but just good to have them, and it's just good to have it just in case. So bear with me. I might make mistakes along the build, so watch the video beforehand before tackling it yourself, or you might have to backtrack like I'll probably be doing in this video. You will see that we actually won't be using too much of the stock Losi, especially in the front end. What I'm going to do is I'm going to throw those just back in, so I know those are the shock screws, so I don't steal them. I'll leave that together. But we are going to need So as crazy as this is going to seem, that's all we're keeping from the original Losi. That's it. All we're retaining. Everything else is swapped out, changed, modified, or something in some form. So this is our chassis. It is made out of 6061 aluminum. It's very lightweight. It weighs like 156 grams if I last recall. It is relatively stiff, stiffer than the carbon fiber, but has more chassis flex than the original chassis. But it is a little bit stronger. I've taken a hit to the curb at going about 70 miles per hour. The car spun out, and because I goofed up with my radio. Last second I spun out, hit the brakes, spun the car around, smoked the curb, going about 70 or so miles. And I did end up causing the chassis to have a little bit of tweak and a little bit of bend, but it actually could have been straightened out. But I've seen stock chassis turn into a horseshoe or a banana at like half that speed. So I was pretty happy there. The carbon fiber chassis is a little wider to have a little bit more strength, but it does have more flex. So it worked really well with an outlaw car where you don't have much suspension movement, and that acts as your suspension. So let's get to building. So first off, what we're going to need is we're going to want to find in our parts tray a short screw. It's like a 6 mil. And the reason why we want that little 6 mil is to go in the dead center. The thread's in the dead center of the bumper. Sorry. Alright, so you can see that that screw has been installed, but we don't want it sticking past the bumper because our servo will rest on top of there. So from here you would grab your servo of choice. So just for demonstration purposes, I have the stock servo here. I'm going to pop that on. Now I'm going to assume what it does from our hardware kit. If you have the RTR, the screws or the washers are already there. So these are, I guess, are the screws for the washer. I mean, the screws and washers for the servo. So steal that right now. Get the body clips out of the way. And with that, we'll screw in the servo brackets. So I'm just gonna back off the screws for a second. Push down so they end up being flush. And now I'm just going to tighten them up. Okay. So that takes care of that part. Okay, so I just grabbed the tallest screws, countersunk screws that were coming from the kit. I know a pair of them, which I believe would have been the shorter ones here. Probably they're like a 20mm screw. Were used for the back shock tower, and then these probably 25s were used in the front bumper. But before we mount the servo saver, I'm going to get the front bulkhead installed because I'm not exactly sure which screw I'm going to need in the front. Just yet, because it's going to be critical to get the right kind of length of screw to screw on the front bulkhead here. So I'm just going to hold off on screwing that down just yet. but I'm going to move right to doing this bulkhead part. Okay, so we're going to grab, where did I put it? No, it's here. Oh, there it is. So this is a little riser bracket for the front pivot block. There's a couple features with this. So this, by raising this up, it gives just enough clearance that we have quite a bit of down travel if you want to have that. It provides like a locking friction nut for the front set screws that would go into here. It also has a little channel for your servo wire to be contained. So we're going to have to do kind of a lot of different changes to the front here. So let's get at it. So I'm going to just pop these off just so they're not less likely to flail around on me. And again, because this is going to be changed anyways, I'm going to pull these out. Pop in this, like all this is going to be swapped around, so it's going to be a little annoying. So sauce that. Alright, so that's, right now we're looking at this. We got the front pivot block and we got the arms. And now what we're going to have to do is we're going to have to swap them from side to side. Reason why is because I'm actually going to install that pivot block upside down and compares to the stock Losi. So pull out those two little screws. Push out the pins. I'm going to take my arm. I'm going to flip it over. Turn it. And now we should have something like this. So I didn't take the arms, I didn't spin around. I took this arm and I flipped it to the other side. So this arm used to be over on this side the other way. So this used to be the top where you have these protrusions sticking out. Now those protrusions go on the bottom and this is the top. So you want to see this cavity with the wider section going forward to your aluminum block. So you got your aluminum block and you still have the shock screws, the shock mounting to the back. All right, so there's your screws for your in the mounting locations for the shock, and there's your aluminum plate to the front. Those protrusions are now on the bottom. Those protrusions will key into this, and it sits in there really nice, drops right in. Okay. So before we kind of leave this down, we're going to take our servo wire, and we're going to just feed that over top so you can see how it fits in that cavity. That's going to line up to the holes on the chassis. This will sit on top and it creates like a sandwich. But what we can do actually is we can actually leave this off for now, and we'll get the screws started, and then there'll be enough play that I can feed the wire through. That way it's not dangling on you. So right now what I need to figure out is what screw we're going to use, and I think we're going to be using the screws that are from the shock tower. They're like a perfect length. So there's the pair from the shock tower that will be used in the front too. Where did the screw run off to? There it is. So I just got those two started now. And we're going to use these screws here, I guess, to hold the servo down. So we're going to take our wire, feed it over top of the tab that's meant for the set screws for droop. Feed it underneath the servo hold down, as you can see. So now that's there. And then we'll just snug these up a little more so that the servo doesn't go flying around. Alright. So you can see though, I can still move that wire around, it's still free. Alright, so that's kind of held in place. We'll go and we'll install the back two. And for the back two, we're going to use, we'll probably go ahead and we'll use those two other screws for the front. Just gonna make sure it's all snug down. That's good. So now, if you are, it might be hard to see, but there's the screws just from the top. If you happen to have any plastic shavings from threaded in, make sure you clear that away for the steering rack, which we're going to install next. So there's this kind of almost a C channel or a J looking piece, and we're going to go ahead, line this up into the front. We're not going to push it all the way in, not just yet, just because it makes it a little easy to get this reason. But you can see how we've almost made a full cavity enclosure going on now, because we have that little tab sticking going down. We're going to go grab two countersunk screws. Just probably the average length countersunk screws that you pulled off the car, like the ones you used for the brace. There is going to be two holes. And that's why I say you don't want to push it all the way in yet, because it'll just make it easier to get the initial thing started. So once you get it started, you can then push it back. It just so you get it just gonna have the countersunk head cleared through. I'm just going to tighten them up, make them snug. You want to make sure that the head of the screws are sitting recessed in there so it doesn't stick out and hit the servo rack, so to speak. So that part will just slide in there like this. It might be stiff at first. You can sand it down to smooth it out a little bit, or make a little small profile, put some oil on it. But over time, it should wear and work itself in, so it'll be really smooth and working. Nylon works really well as it slides well on itself. It's kind of not self-lubricating, but it just has a low friction coefficient. So, as we got that on there, this fits in good. We're going to go ahead and grab our ball studs, and we're going to start inserting them in. So this first further tab out here is to connect your servo. Now, because of our caster blocks, this right here is a 15 degree. I don't know if you can see, there's a 15 degree. I have a 5, a 10, and 15. If you're using a 5 degree, you would screw on your ball studs right directly onto these recessed perches. Or not recessed, but protrusions. Perches. If you're using a 10 degree, then you want to put on a 1 millimeter. But because we're using a 15 degree, we're going to want to use 2 millimeter of a perch. And the reason why we're sticking that on and doing that is so that it kind of helps to keep the length, or not the length, but help to keep the tie rods for the steering relatively flat in comparison to the upper tie rods for the front links. If you run the 15 degrees and you don't put those spacers in there, then your tie rods are going to be angled down, would be angled downward for the steering. And also, like I said, if you were to run the 5 degrees and have those spacers, they'll be pointed up. So you would introduce bump steer at that point. So just by putting those spacers, it helps to reduce that. So I have 2 1 millimeters right here off of these little clips that get included. Or not clips, but washers that get included on a little parts tree. I'm going to put 2 1 millimeters on here. There's also 2 millimeter washers on there. Just that tree has them all used up on another vehicle. But we're going to feed on 2 washers, total of 2 millimeters. And with that, we'll screw it into the steering rack. Just to it snug. Again, you don't want to risk stripping out the plastic. It is 3D printed parts. It's not as strong as injected molding. I try to make the parts more robust because of that fact. You'll notice that the parts are more bulkier than what a standard nylon piece, injected molded piece would be. So there's that. So now you can see how that is raised up by the 2 millimeters in comparison to just being on those little the bulges that stick out. And that is because we're using 15 degree caster blocks. The 15 degrees are included with the kit. You can buy the 5 and 10 degrees separately. So that will sit in there like that. And now, because all of that is installed, we will now finish off with the servo. So you can just pop that link on there. And with 2, I'm going to write this down, 2 25 millimeter countersunk screws, we'll install the servo. So by installing the servo, it actually acts as brackets, or hold down for the front bumper as well. Okay, so that's there. So I unfortunately got these several blocks wrong, so I had to recreate them. The holes need to be shifted inward to better accommodate fitment. So that's my bad. I have to reprint them, but I just have it held down in place with the one screw just for now for demonstration purposes. Alright, so now we're going to go and work on the front block. So because we flipped the arms around, that's why we had to take these off. So we're going to take off the steering knuckles because they're going to be flipped around to face forward to the servo. Okay, so put that off to the side for now. We're going to grab steering blocks. So the right, oh sorry, I apologize. Ha ha ha. I want to screw myself over there. So we're going to pull off those ball studs. And what we're going to do is take these caster blocks and put those off to the side. Because these are the caster blocks that I've created, being at 15 degrees, so they have more caster compared to stock. The stock ones, on the stock chassis, it had about 25 degrees of kick-up, which helps, the kick-up helps with stability, having so much caster going on, but because we're now flat, we would only have had 5 degrees, because initially the car had a total of 30 degrees, which is a lot. Again, it's based off of a short course off-road vehicle, which would use that caster for stability on the off-road. But with us being on the road, 15 degrees is plenty. It's actually that's more than a lot of kits happen to have. A lot of drag kits only have like 5 degree with them being flat, but I have 15 degrees, which improves stability, making it pass. But like I said, you can buy 10 and 5 degrees if you choose to use a lesser caster. So now the great thing about making my own caster blocks is it allowed me to put in floating body mounts into the design. So by doing that, it really had simplified a lot of the car in the front end. Okay, so those are installed. We're going to grab our steering knuckles, and we're now going to be facing them forward. So because of having the 15 degrees, you can see how far back or how much this is tilted my steering knuckles. So if we didn't add in those spacers, the height of this would be much higher than with the ball studs to be on the steering rack. I was going to flip one over. So I'm going to pop this off just for now, just because it's going to be in the way. You can see now, I know it's not being supported straight up, but that sliding back and forth, I have the steering. And by having this going on where they're going to be the same length of link as my front tie rods, I'm not going to have introduced bump steer like you would have when you have a servo with the servo saver directed right to the knuckles. So shifting that over, threading the ball stud up here. So just a note, probably be easier right at the start to have threaded these ball studs onto the bulkhead. That is my bad. But if you make note of installing the ball studs first, it'll make things easier. So we're going to take another set of ball studs. And you're going to throw them into here. And like that, we're installed. So because of our links are off right now, that's where we're kind of hitting. But they should just about clear. But even still, that is a lot of steering that you end up having. More than you would use anyways. Trying to see what will open the screws for the front. Where's my front shock tower? How do I do that? I always do that. I got skills that cause parts to always go missing. Just kind of trying to say, look at the front shock tower to know what I needed for the front screws. But I'm not necessarily seeing anything longer. So I'm going to assume those two were the front shock towers. I don't think we need as long a screw. Have that. Yeah, I guess we got. So I think these are the shock tower screws. They're 25 millimeter. feed them in from the back side here. Just caution, if you're screwing that in, it could get hot just because of the friction of the plastic cutting threads. So we're going to slide in our screws, grab our front shocks, that's our rears, these were the fronts, but again you're going to want to take out those limiters. Pull those two screws out now. Those are the screws that hold the bottom of the shock. So you would put the whatever you need to in the front shocks. Also, you can pull these clips out because you have to readjust it anyways, and that's probably way too much clips in the front anyways. So that's the one side. Clips out. Push this forward. So you might not be fully tightening the front shocks when you're using the stock ones. Or you put a spacer in behind it, about a 2mm spacer behind the shocks, just because of the shock top of the cap is just hitting the shock head. If you use any aftermarket ones that tend to be a little bit smaller diameter, you'll be completely fine. It's just that the Losi ones are a relatively bigger diameter than what most kits are using. So that's the front. I didn't get to tapping these on this plate just yet, but you would use an M3 set screw. There'll be 3 lengths provided. There'll be a 6mm, an 8mm, and a 10mm set screws that you could use in here to adjust your droop, so you can limit how much down travel you have. The reason why I'm providing 3 different sets is just because of you really don't want the screws to stick out past, because if you scrape it doing a pass, you'll wreck where you put your hex in. You have a hard time getting out. So you don't want the screw to stick past, but you also want to be having threads into the aluminum just to have more strength. So if you find that you need more than the 6, then you jump to the 8. More than 8, you jump to the 10. So next up, we're gonna go to our we're going to go to mounting our antenna tube. So we're going to go and grab a relatively small screw. It's probably like a 6mm button head. Feed it through the hole on the very top of the triangle so it sticks out top. So looking like this right now. Grab our antenna tube. And it has like a hex profile on it, so you can grab onto it a little easier. And I'm going to orientate it so that it's facing towards what would be the bulkhead. Okay, so that's like that. We're going to grab 2 more button head screws, preferably longer ones, just because we don't want to. We got more longer ones than shorter. So these are like an 8 or so, 8 or 10. I'm going to feed them through these little eyelets. Get them started. And then we're going to go to the back side of the bulkhead where we got 2 screws where the ball studs went into, or 2 hole openings. And we'll use that to fasten our receiver mount. Again, you probably want to go back and forth just because of how it's kind of walking in. You don't want to go tighten one side down, having the other side out, and you might crack the plastic. So just go back and forth. And just get it snug. Don't have to reef it down. Now you have a receiver mount that you can get your servo, from your servo, your speed controller can attach up to there. So that gets it nice and out of the way. And then next up, we're going to go ahead and put our battery mount down here. So with the Real Street, this would be like the battery tray. It fit our standard pack battery, as you can see. And we can orientate it in one of 2 different ways. So we can either orientate it straight on, like this, or if we need to get more weight, we can rotate the battery pack 90 degrees and get it to be really up front. Get the weight right up there. So I will mount it up front just for demonstration purposes so you can see how much forward weight you can have. There is different ways to get the servo wire down if you need to, if you want to mount your wire down towards the chassis, or if you were to actually bring your wire up from your speed controller. So you can see if you were to mount it inline, there's little side paths made into it. So you can run your wire down or your speed controller wire up and then up that way. Or if you're going to have it inline, you want to have your receiver a little closer to your speed controller, you can mount it like that, and then that creates a channel for your wire to go, and it's nice out of the way. So with that being said, we'll screw that down. So we're just going to go out, and probably what's going to happen is, because we're going to need short countersunk screws. So we got one there. We need 8mm. So included would be 2 additional countersunk screws. Now to get them started, first outside the part, just to cut the thread. Just a matter, again, the thread's the first bite. Okay. So with the latest chassis, there's actually holes going way right back to where the motor would sit. So these holes will actually travel all the way down to here. So you can move this battery, having it 90 degrees right to the back if you have weight to the rear. So you have a lot of freedom to get your weight balance whatever way you want it to be, front to rear. Okay, so that is now there. So you can slide your battery in. And then what you'll see is you can look on your hexes or your battery strap. And that battery's not going anywhere. So that holds it down really nice. You got a lot of forward weight, especially if you need that for real street. This will get you up to like a 50-50 weight balance, depending how you lay out your electronics. Okay, so now we're going to go and start working on the back of the car. So we are going to go ahead and install the, I guess, the bottom rear pod. So we're going to grab 2 button head screws, like the standard length ones that you're pulling out. So they're like an 8mm length. Before we do that, we're going to screw on the shock tower. Now, what we're actually going to do is think. Okay, yeah. So we'll screw this on. Okay, so the shock tower's on. Drop into the rear pod. Grab our 2 screws. Feed them up. Now, if you choose to, you can get something like a brass weight or put lead weights, and it'll fit. If you need more rear weight, it fits snugly right up in there. And then when you stick on your spacer, that's over 60 grams of brass weight can be fit into the rear underneath the transmission, which will end up being right in line with your wheel axles. That, or you can grab lead weights, like the ones that are used for tires, common used on RC cars, and throw it in there. Alright, so we got that mounted. We're going to go ahead and we'll attach our rear pod here. But we're not trying to think. So we'll attach this part on. So we need to get that countersunk screw. Fire that in. All right. I'm going to put in the screws to reattach that brace. We're going to go and install that bulkhead piece up. So, because we don't have the wheelie bar anymore, there is a tube that goes across there to bridge that gap. Okay, so that is there like so. We're going to go ahead and grab our bottom bulkhead piece, fit it down in that little pivot where the bottom of the wheelie bar went. We're going to grab our screw that was used. Oh, there it is. And we're not going to need the nylon locking nut at this time, so we'll be able to use that elsewhere. Okay. So now that's all together. So what we did is we first went ahead, we mounted the shock tower to the transmission, put the transmission to the riser block. We fired 2 screws, M8, into the front of the transmission sitting here because there's 2 hole openings. We put this brace back on where we put the long screw through here, 2 screws back here, ran the long screw where we put a plastic tube in the middle to take up that gap. And then we used the long screw that was for the wheelie bar to mount on this brace. And that's where we currently stand right now. So the next thing we're going to do is, let me get my bearings. Okay, so we're going to go ahead and grab 2 12mm set screws. Mark that down. That will have to be included in the kit. And I'm just going to feed these in now just so they're out of the way. It's easier to get to at this particular point. So please bear in mind, with using this whole unit, you have to run either the spacer or the wheelie bar because of the height of this piece here. So now that's all there. What we're going to go ahead and do is we'll screw in, actually, we'll build up the rest of here. So using our 20mm screws that are from the kit, or from the car already. One. So I'm just going to finish this off by hand. Okay, so that's there. So we got that on. Gonna take 2 countersunk screws, feed them through the bottom, and we'll thread into the brace, the rear brace. Alright, so nice thing is we can actually pivot that. So now we got our little spacer back here that lines up as such. What we'll do is we'll thread this all together. So using 30mm countersunk screw, line up the holes. Alright, so we just fired the 2 screws. That go into the, I guess, the motor shroud. I don't know if you can see that, but 2 screws are installed there through the bottom. That's going to hold that in place, then we can kind of continue on with the car. So we're going to now just install this bracket on. So first off, we're going to take it, slide it through, push up, grab our insert, slide it in behind underneath it. It's going to be a relatively snug fit, so you might have to naggle with it a little bit. Darn it. Hopefully we can use the screw to kind of wander our way through. We can use a screwdriver. So that's going all the way through. Grab two 30mm cast iron screws. So now that's screwed in. So you can see the screws protruding out a bit. It's gone through all that. We're going to go ahead, do a rear shock tower. So we're going to need an additional pair of 30mm. Knock that off. And those are going to go right in through to the back, into the shock tower. Okay. Next up, so that's all really secured. We're going to grab our pins for the back arms. Insert those. Okay. Grab our rear arms. Now our rear arms are going to be going gull wing, they go forward facing. As such. Okay. So now next we're going to go ahead and grab our rear pivot block to line those two up. So then once again we have our spacers, and depending on how many spacers you put in the rear of the car changes your anti-squat. I'm going to only have one spacer in the rear right now, which will make it neutral in terms of the anti-squat. We're going to need additional 2 more 30mm screws. For a total of 6. And that's going to make its way up. And using 2 of nylon locking nuts that are from the initial front shock tower. Started. You don't need to go super tight on them. There, it's enough to hold it down. So that's there. That's installed. So now the next thing we're going to have to do is we're going to take our rear knuckles and we're going to flip sides so that this it sticks a little further back. So I just took the one from the one side, gonna flip it over. Repeat to the other side. Put those screws back in to hold the pins in place. And then, of course, what we're going to do is we're going to do our favorite thing, and we're going to flip these ball studs to the other side. So with the ball studs to the other side now, pop our links back on. Give it a spin around. Make sure our drive shaft is in. Pop on our link. Alright. So again, you can see that our tie rods are relatively straight, straighter than before. So right here, we're going to install back our slipper. So we got our spacer in there, one slipping plate, our spur with slipper pads, the other slipper plate, tension spring, our nut, and grab our housing cover. Paper. There it is. Alright. So thanks to the reduction of parts in the front steering, we actually have the ball studs we need for our rear floating mount. So those ball studs are going to be in the front side, and they're going to go here. Okay. So what we'll do now is we'll attach the shocks. Get those out of the way. Let's pop you on. Pop that on. Grab our rear shock. Again, you want to remove all the limiters out of the shock beforehand, because you no longer need that. You can adjust it externally. So just like we do in the rear motor kit for the stock chassis, we're going to grab 2mm spacers off of that plastic part tree. Feed a screw through. Feed our washer. And just like that, our shocks are installed. And the reason why we have that spacer put in there is just that it provides just enough clearance that you're not really into your spring's not into your tie rod. All right, we're gonna get onto the floating body mount. So with our brackets here, we'll just throw these on. Okay, that's on. Screws. Okay, so that's all taken care of. So now what we're going to do is we can grab our, which again we had actually plenty of, so we're going to grab our M3 20mm screw. We'll grab our shim, a 1/2 mil shim, washer, or two 2mm shims, or feed it spin that over. So I have my body posts forward, so they're going to be in line with the tire, putting that weight on there. Plus, because of my links, it'll be more in line, so I have less twisting going on. So, second washer on the back side, and then we're going to grab our third nut that's in with our hardware that we pulled out from the initial wheelie bar. Thread that on. So that's snugged up, but that slides really well. Okay. Take our back, leave our links. Pop the link on. We'll do. Sorry for spinning this around so much, because we got the hardware. So we got grab from in the package there, because we pulled the hardware off there. 0.5 millimeter shim. Feed it into the back hole. Supplied nut. Let's make 2 of those. Slide that down. I want to make sure it's pivoting. Do the same to the other side. So screw, shim, feed it into the hole. Supplied nut. Cool. And snap them onto the rear hubs. And like that. We got rear floating mounts. And now for the front end, these you're going to want to have these adjusted at 0 as best you can, or whatever you happen to have it, but you want to make sure these are adjusted to where you want them to be before mounting your holes in your body, because as you can see, they're kicked in right now because these are so cambered in from the stock position. So make sure you get that aligned up how you want it first. Grab our 2 existing screws. Cool, I found the hole right away. That's fed through. We'll do the same to the other side. And it seems like if you have just a complete hole showing right above the top of the caster block, then that's where it lines up for the hole. So when you just have a full hole exposed, that's where you want to start screwing it in. And there we go. So just like that, we've done a complete conversion. I'm just gonna clean up my additional screws here. So going over the car with all the features we have a front mounted servo, which is going to a bell crank steering setup, like a rack and pinion, which as you can see is that your tie rods are about the same length. For your steering tie rods are about the same length as your tie rods for your upper link. By having that, you're going to really reduce the bump steer, especially, again, because it's a spacer, your links are relatively straight in comparison to each other. So you got that. You got front floating body mounts, much lower profile front bulkhead than stock, so you can have your body slammed down a lot lower than as usual. We have droop screw hole locations in the front, so that you can now adjust your droop overall, which limits how much up travel you have in the front end. And then with the supplied with the kit are clips that you snap onto your outside of the shock onto the shock shaft, which limits how much bump stop you have, so you don't slam the chassis down the ground. Moving on, we have a fully adjustable battery location where you can really move your weight balance on the the current chassis. These countersunk holes go all the way to the back, so you can have your battery situated all the way back here, speed control in front of it, put in a lot of rear weight bias if you need that, or you can have it all the way frontward if you need that you already have tons of grip where you're racing. You have that option to do so. We have a place to mount your receiver right up front. Again, you can mount it anywhere you want in the chassis if you have the room, but there's this place right up front here with a spot for your antenna tube. I like running antenna tubes. It's just kind of a nostalgia thing for me. So you got this whole layout here to mount your electronics. The chassis is relatively stiff. You don't have a lot of chassis twist, but you got some flex going on, but not tons in the chassis twist. The carbon fiber chassis has less kind of flex going on, but has more twist. So depending on how you need the characteristics of your car to be, you go one way or the other. As well as the carbon fiber chassis variant is lighter. It's probably about 80 grams lighter than the aluminum chassis, but for real street, it meets it's underweight as it is. Looking at the rear, let's flip it to the bottom. We have droop screw locations in the rear, so you can limit how much droop you have going on. And again, do the same matter. You can put clips in there, so you no longer have to have those rubber spacers in there, so you can get that really close. Again, the spacers included are 1, 2, 3, and 5 millimeters, so you can keep them really close and consistent. We got a full-fledged floating body mount, so that rides on bearings. It doesn't matter what you have for camber in the rear, it will keep this true. The body post goes right up above your tires to reduce the body flexing. As you can see, it is now set up as a mid-motor. It's a mid-motor with a 3-gear transmission, so the rotational mass of the motor will inherently make, when you get on throttle, it's going to kind of try to keep the front end down instead of wheeling. So when you launch, it's going to push weight forward instead of going backwards. In the rear, we have the ability to, because of spacers we can put in the back, we have the ability to adjust our anti-squat, which helps with weight transfer on initial acceleration. So if you need a little bit more rear grip, you can add a shim in the back, which will aid and make it easier for the suspension to take weight. If you got too much going on and you need to reduce that, you can take the shims out, which will lower the back of the arm, again making it harder to transfer weight over to the rear. With our riser setup, we have a cavity underneath the transmission now that you can throw weight that would be directly in line with your rear wheels. Our back end is raised up about half an inch or so, and what that means is that you can get your chassis sitting low to be about say half an inch off the ground. Your axles will be horizontal; they'll be parallel to the ground, so you will have less twist going on. It's going to have less chassis movement and whatnot going on. It should prolong the life of your axles as well, because of them being straight. They're not kicked off on an angle, which would help cause a twist. It should improve launches, being more consistent. And I mean, that more or less breaks down the features that this has. Very happy with the kit overall. It's definitely affordable. Pricing will be posted very shortly, probably at the time of posting the videos. Pricings will be attached to each kit variant. Like I said, the Real Street, this is the Real Street front bulkhead. The Outlaw bulkhead is much lower profile. It's not too much taller than what your links are. So actually, like, the bulkhead sits lower than what these caster blocks will be. So they'll actually, you can have your front tires rubbing right on the body and not even touching the bulkhead in the center, depending on what body you have. And now they require, to use that front bulkhead, you need to use touring car, like 1/10 scale touring car shocks. There is the option of buying the kit with the shocks included for an additional cost, or if you want to source out, or you already have shocks, you are free to use those. Just grabbing a touring car now, you can see that this is the size of shock that will be used in the front end. They're not too long, but that is the shock length. You would take off this eyelet and you would put the eyelet from the original shocks on there so that it fits in the arm. And with these shocks, you still have over 1 inch of front travel of suspension movement. So that concludes the building of the full-fledged kit. Thank you for checking out the video. I hope you enjoyed it. I hope it was informative. Hope you were able to follow along. And I do hope that you enjoy the kit that I've developed and you win races. Again, this is not going to be the fastest car out there. I'm not going to say it's going to beat a Patriot from Custom Works or an R1 DC1. This is to take a relatively, actually very cheap roller. They were at the cheapest at $70 US. You're taking a $70 roller, you're going to throw on a kit that's roughly the same price as that roller, so you're like $150 all said and done into this roller that you're not going to be breaking records, but it can get you in there racing Outlaw, Real Street, be very competitive at a low cost, has all the features you would expect on a higher end kit for a lot less. Again, thanks for checking the video. Hope you support me with this, and we'll talk later. Bye.